All right, so today we're going to look at 1.5. Okay, 1.5 is on segment and angle bisectors. Okay, as we said earlier, bisecting something means to cut it in half. So we're going to learn how we can use the two tools I've mentioned in geometry, a compass and a straight edge, to cut a segment in half and cut an angle in half. There won't be any measuring involved to do this. It'll be what's called a construction. So it's a geometric way to do something exact without using any kind of ruler or tape measure. Okay, when we cut things, especially segments, in half, we create this thing called a midpoint. Okay, and the midpoint of a segment is basically the point, which we label with coordinates, that divides the segment into two equal parts. Okay, so we could say something's divided into two equal parts, or we can say it's bisected. Same thing. And then we can draw in a bisector. Okay, so we can just mark the spot with a point, or we can mark it with another segment. We can actually draw a line, and that's what we'll do today. So I'll give you something that has a length, and then we'll draw another line right through it that bisects it. And we're going to draw what's called a segment bisector. Give people a second to copy that down. So if you draw either a ray or a line or a plane, okay, any of those things right through the midpoint, that's called a segment bisector. Once we bisect something, we want a way to draw that so that somebody knows we have two segments that are exactly the same, that we've cut them in half. Okay, we talked a little bit about how we would do that using a little mark on the line earlier. Okay, in our book, what they do is they use these red congruence marks. So they're small vertical or horizontal lines that go right on the side. Okay, and they look something like that. So in that picture, we could prove that M is the midpoint of segment AB because segment AM and segment MB are exactly the same length. And we know that because of the little marks that have been put in. If those marks aren't there, then we can't assume M is the midpoint, even if it looks like it is. They've got to put those marks in if it is the midpoint. Okay, in the picture next to it, it's pretty much the same diagram. Segment AB is bisected this time by a line. Okay, I decided to draw a line going right through the midpoint. Okay, so we would say line CD is a bisector. Okay, that's a bisector. And what's it bisecting? Segment AB. So it's a segment bisector. Okay, just summarizes a couple things I already said. M is the midpoint of AB, and AM equals MB. When I write this on the bottom, AM equals MB, what am I saying here? Anybody explain what that means when you use the word equals versus like a congruence symbol? What am I specifically referencing when I use the word equals? Yeah?
They're the same.
What about them?
If you add up AM and MB, it's going to equal AB.
Okay, so when you say add what?
The length.
The lengths, right. We're talking about the measures of them. Okay, when you use an equal sign. The measure of the segment. They're equal. If I use a congruence mark, now I'm talking about the actual object. The segment itself is congruent to another segment. Okay, and then next to it, line CD is a bisector of segment AB. Okay, any questions on that? All right. All right, so the two tools that we use in geometry quite a bit are a straight edge and a compass. Okay, so a compass, well, I'll show you an example of what that looks like in a second. But a straight edge is just a straight object. Okay, it has no markings on it. It's not a ruler. Okay, rulers have marks to indicate length. Just imagine like your ID or a straight piece of metal, something that's blank. Doesn't have any markings on it. And we're going to do a construction. So a construction is when you draw something geometrically, basically using these tools. So if you see a question that says construct, that means they want you to do something geometric using these couple tools. When you guys take the, well, maybe not the MCAS, but after you guys, when the new test comes in, they're actually going to have to do constructions on the test, on a computer screen. So they're going to have to show how to do it, and the screen is recorded so somebody can see, do they know how to use the tools to do a construction? So it gets a little more hands-on. Okay, first thing we're going to do is construct a segment bisector. Does anybody know how to do that? If I just gave you a straight segment, gave you a straight piece of metal, gave you a compass, and said, find the middle of that segment. Does anybody know how to use those tools to already do that? No? Okay, so let's take a look at how we do it. So I'm going to give you the steps first. And then down below I have an actual example. I'm going to go through and do it. So to construct a segment bisector, first thing you want to do is we're going to place the compass at point A. Let me show you the diagram so you can get an idea of what this is going to look like. There's my segment I'm going to bisect. Okay. Segment AB. Okay, so first thing we're going to do is we're going to place the compass at point A, and the compass opens up. Okay? We have to open it up to at least more than half of the width of the segment, or this won't work. If you open it up less than half, your arc that you draw isn't gonna work. Okay, so what I'll do is let me do it as we're writing the steps. So place the compass at point A and open it up to more than half of the length of the segment. Okay. So let's take our compass. Let's draw that point. Okay, so that's the end of the compass you want to put right on the point. And you can tell I've opened it up more than half. So we take, and we're just going to draw an arc. If I kept going, I could make a full circle, but for what we're going to do, we don't need a full circle. We just need an arc. Okay, now step 2 says I have to keep the compass setting the same. Don't change the width of it. If you change the width of it, we got to go back and start over. Okay, but keeping the compass the same. Now put it on point B. Okay. And I'm going to draw an arc from there. Okay. Let's see if I can switch. Yeah, that's what I want. I just switched it around. So now I'm going to draw my arc here. All right, so that's step 2. Now it says we're going to use a straight edge to draw a segment connecting the intersection points of the arc. Okay, so we're done with the compass. Take a straight edge. Okay, using the smartboard, I can automatically draw segments that are straight. Okay, so draw a straight segment and put it going right through the intersection points of the arc. Okay, now, if you were trying to do a nice drawing on paper, we're done with the arcs. We could erase those. We don't need them anymore. So what I've just done is I drew a segment. And I'll try to stick to using the color red for now, but keep in mind that if you use a little black tick mark or green, color doesn't matter. The book generally uses red. And let's call this the midpoint. So segment AM and segment MB are congruent. Their measures are equal. Okay, we didn't use a ruler at all to do that. That's a construction. It's a geometric drawing. Any questions on how to bisect a segment? So if I give you a problem like that on a test, and I give you a compass and a straight edge, everybody feels comfortable they could do it? Okay. So what I'd look for on the test is that I see those arcs drawn. Okay, you just leave them drawn. That way I know you used a compass to do it. Okay, so that's how you bisect a segment. Okay, if we look at doing the same kind of thing on a grid, we can start to use a little bit more algebra. Okay, we can use a formula. Now, this is not a construction. Okay, if we know the two endpoints of a segment, mathematically we can find the midpoint on a grid. Okay, because a grid already has markings for us, okay, a coordinate system. So here's a segment where I've drawn 1, 3, okay, as one of the endpoints. 6, 3 is the other endpoint. And the midpoint is 3.5, comma 3. Anybody see how I got that? How you can use point 1, 3 and the point 6, 3 to somehow get that midpoint. How can we do that? Yep, Kira?
Add them up and then half.
Yeah, can you do it separately two times? Add the x's up. 1 plus 6 is 7. And take half of 7. And then do it for the y values. 3 plus 3 is 6. And then take half of 6 and get 3. What are we really doing there? If you add up two numbers and take half of them, what is that called? Oh, Justin? What's that called when you add up two numbers and then take half of them? Or divide it by 2. Well, let's try it with an example, and then I bet you'll get it. What's 50 plus 100? Yeah. 150? What's half of 150? 75. So 75 is the what of 50 and 100? It is, but what would you call it, like, say, in a classroom setting? If I was doing that for you, it's the mean, exactly. It's your average. Yeah, you're averaging them. All right, so if you take and average the x's, average the y's, you get the midpoint. Okay? That's all you're really doing. So that's going to lead us to our midpoint formula. Okay, so suppose we have 2 points, A and B. A has coordinate x1 and y1. B has coordinates x2 and y2. And there's our formula for finding the midpoint. Average your x's, average your y's. Okay, in algebra 1, you probably did this formula, and the same formula you did the distance formula. They're usually pretty close, pretty close together. Okay, so I've already explained what you're really doing is just taking the mean of the x's and the mean of the y's. Okay, we've already said that. What I want you guys to try is take those 2 points, see if you can find the midpoint. Okay, I've already labeled them x1, y1, x2, y2, so try it the way I labeled it. And then if you have a second, try switching the labels. Try letting point B have x1 and y1, and point A have x2 and y2, and see if it makes a difference. I think about it logically first. Should it make a difference? And then try it and see if it actually does. Okay, so we'll take a look at that in a second. All right, let's find our midpoint. Okay, anybody give me the just the first half of the midpoint formula to find the x's? And do what plus what divide by what? About James?
x1 plus x2 over 2.
Yep. So in this case, what's x1?
Negative 2.
Yep, negative 2 plus
5.
5 divided by 2. Okay, we'll do that out. Somebody else give me the other half to find the y values of the midpoint. Brian?
3
Yep.
and negative 2.
Yep, so 3 plus negative 2, which you really could just do 3 minus 2. Divide by 2. Okay, so negative 2 plus 5. Denver? What's negative 2 plus 5? 3. They don't ask for a decimal, that's fine. Just leave it as 3 halves. If they want a decimal, you could put 1.5. Okay, and the y value? How about Sarah? 1 in the numerator, divide by 2. So 1/2. There's my midpoint. What type of number do you think is easier if you have to graph, a fraction or a decimal? Yeah?
Decimal.
Yeah, the decimal is going to be easier. Because then you know exactly, like if it's 1.7, oh, you go 1 and then a little bit before 2. Okay. But if you had as a fraction, you might not recognize the decimal. Okay, so generally, we'll use a decimal when we have to graph it. Okay. So give that one a try. It says find the endpoint of segment AB. Given you the midpoint. Midpoint's 2, 4. One of the endpoints is negative 1, 7. I want the other endpoint. It's a little different, but see if you can figure that out. Okay, so one way to do it is algebraically. Okay. So we know that we want the midpoint to come out to 2, 4. Okay, let me focus just on the x value for now. I want the x value to come out to 2. Okay. What's one of the x values that I already know I'm working with? How about Olivia? Yeah, negative 1. Okay. That's one of the x values that we're working with for point A. Dakota, what's the other x value? That's the midpoint. We've already used that. What's the other x value for my segment? It's not numeric. X. So I know that somehow I want to get a midpoint of 2, and I'm going to take my 2x values, I'm going to add them up, and I'm going to divide by 2. If I can solve this equation for x, then I can get my other x value for my segment. Okay, Luke, what would I do to each side to solve for x?
First you gotta find out what divided by what equals 2. That's
Yep. But what if it was more complicated? Say we had a bigger equation. What would, do you know the steps to solve it
Too complicated.
from Algebra 1? All right. So later today, I'm going to give you some that might be hard to guess the answer. So you got to have an arithmetic or algebraic step here. Yeah.
You have to get x alone.
How do you do that?
We would add 1 first.
So addition and subtraction, when you're solving an algebra equation, that's the last step you do. Well, generally the second to last step. We can't do that here because of this divide by 2. So first thing we have to do is get rid of the divide by 2. What's the opposite or inverse of dividing by 2? Multiply by 2. So you get 4 equals -1 plus x. And how would I get the -1 on the other side? Yeah, just add it. Okay, again, easy enough equation, you could have guessed it. Very quickly, we're going to get into equations you can't guess stuff anymore. Okay, but so those are the 2 steps. So now you got x is 5, and we do the same thing for y. Okay, I know I want my midpoint to come out to 4. 7 plus something divided by 2 has to give me 4. Okay, so we're going to get 8 equals 7 plus y. Or in this case, y equals, yeah, 1. Okay, so my midpoint is 5, 1. That's an algebraic way to do it. If you did it geometrically, you could use a grid and do it that way and draw it out. Okay, but we'll stick with the algebraic way. Any questions on that? All right. So let's talk about angles. Okay, so an angle bisector. Okay, pretty much the same thing as a segment bisector, except now instead of cutting a segment in half, it's going to cut an angle in half. So an angle bisector is a ray that divides an angle into 2 adjacent angles. Okay, we talked about what that means. They're adjacent and they're congruent. So in this one, you would say ray CD bisects angle ACB. Okay, Anthony, can I switch the order of the C and the D when I'm talking about ray CD? Why not? What happens if you switch this order of the C and the D? When you're talking about a ray. Does a ray go in 2 directions? Okay. So what happens if you switch the order and the ray is pointing one way?
It would go the other.
Yeah, it would point the other way. All right, so we can't switch the order here. How about when we describe this angle? Could we switch these letters around and get a different way to name angle ACB and still have that be okay? Yeah.
You can switch it to BCA.
Sure, we can switch that to BCA. That would be fine. Okay, and then in our book, what they're going to do to show you the 2 angles are congruent, they're going to put these red arcs. Okay, so if we see a picture and there's a couple angles in it and those have red arcs on them, that means they're congruent. If you had multiple angles and or multiple sides and you wanted to show congruence, you just keep adding more angle lines or more marks. If you want to say that's congruent to that, and that side's congruent to that side. Okay, in that case, that would show that this figure, especially if I put in that right angle, that's a rectangle, which is a specific type of parallelogram. Okay, any question about how you show congruent angles? Use those arc lines. All right, so our second and last construction for today is how we bisect an angle. Okay, anybody know how to use the same tools I had before and bisect an angle? A little different than a segment. All right, so we're still going to draw some arcs, but not quite what you did before. This time you're going to put the compass at the vertex of the angle. And we're going to draw an arc that intersects both sides of the angle. Okay, so let me do that. And we'll label the intersection points A and B. Okay, so here's my angle. Here's my compass. Okay, so we're going to put the compass put it right at the vertex. And actually, let me make that a little bigger first. There we go. And draw an arc. Okay, label the two intersection points A and B. So that's step one. All right, step two. We're going to put the compass at point A, and then we're going to draw another arc. Okay, when we draw the arc at point A, it's important that we don't change it. Okay, we've got to keep it exactly the same, because we're going to do it at point B as well. Okay, so let me put it at A and draw an arc. It doesn't have to intersect the other arc we just drew. It just has to intersect the arc I'm about to draw now. And I tried to make it a little smaller to show you what happens if you don't make your arc big enough. I don't think I made it small enough to do that, though. Well, just barely. So the two arcs are, you can see it doesn't really look like they're crossing. And that's because the setting was just a little bit too small. Okay, if it was even smaller, they wouldn't even touch. Okay, so I should probably set it a little bit bigger. Okay, when you're drawing a construction, that happens a lot. You don't quite have it the width you should. Okay, so make it a little bigger, and now we'll do it. Okay, so there's one. Do it here. There's two. That's much better. Now I can see exactly where those arcs are crossing. And then step three, use your straight edge to draw a line or a segment right from the vertex, straight through where the arcs cross. Okay, so about like that. That segment that I just drew is bisecting the angle into two equal parts. Any questions on drawing an angle bisector, constructing an angle bisector? If you need the steps again, they are in your book, or you can just take a look at the video showing the steps again. Okay, in this class, there's about 10, maybe 10 or so constructions we're going to learn. Okay, these are two. After a while, the constructions get really complex. So we're going to stick to ones that are about this level and maybe just a little bit harder. That's an angle bisector. So let's look at example 3. Okay. They didn't draw in congruence marks here, but they did tell me something up above. They're telling me ray FH bisects angle EFG. Okay, so I know that this is an angle bisector. Okay, the measure of angle EFG is 120 degrees. Find the measure of EFH and HFG. Okay, what would the measure of angle EFHB. Given that EFG is 120, and it's being bisected. Kira?
60.
60, how come?
It's half.
It's half, right? Okay. If it's being bisected, it's cut into 2 equal parts. So that's half. Okay, how about the measure of angle HFG? Yeah,
60.
it's also 60. Okay, for the same reason. Okay, it's being cut in half. Right, this is another geometric shape we'll study. It's called a kite, kind of looks like a kite. And it has 2 angles that are bisected. Angle EKI and angle ITE. So I want to find the measures of those 2 angles. All right, let's take a second and see if you can figure out what EKI would be, and then the measure of angle ITE. All right, so the measure of angle EKI. Anybody think they got that and can explain why they got what they got? Nathan?
EKI is 45 degrees.
Well, we know if we look at this half of it is 45 degrees.
Oh, then it'd be 90 degrees.
Yeah, it would be 90 degrees. How come?
Because both sides of it are 45 degrees.
Right. And how do you know that both halves are 45? What sentence tells you that?
That they're bisected by the ITK or KT.
Ray KT, yes. Okay, we know EKI is being cut exactly into 2 equal parts. It's been bisected. So if we know what half of it is, it's 45, and the other half is also 45, so we get 90. Okay, and using similar reasoning, how about ITE? Oh, Nick, what would ITE be? Yeah, it's the same reasoning. Okay, we know half of this angle is 27, so the other half is also 27, and it's 54. If they didn't tell us that that angle was bisected, we couldn't do it that way. Okay, any questions on that? So everyone understands the relationship when you bisect an angle. Okay. All right, so in that diagram, there's an angle that's being bisected. Okay, one of the angles is x plus 40 degrees. The other angle is 3x minus 20. I want to solve for x. Okay, so using the exact same reasoning you just used on the previous 2 problems, that will help you to figure out what x is. Okay, just take a couple minutes, see if you can figure that out. If you get stuck, let me know, and I'll come help you or give you a hint. All right, so you give us a diagram where there's 2 congruent angles. Okay, and as I went around, I asked some people, what does it mean when 2 angles are congruent? Okay, so what does that mean? If you've got 2 angles that are congruent, oh, Tanner, what do we know about them? What's equal? So what specifically about the angles are equal? The what of the angle? The measures, right? They're measurements. Okay, and we know the measures of the 2 angles from the picture. Okay, Ian, what's the measure of the first angle?
X plus 40 degrees.
X plus 40 degrees. Okay, he said degrees. I'm not going to put it in the equation because we're going to do some algebra. But when we get our final answer, we want to remember to put it back in. Okay, so x plus 40 degrees. Okay, how about Nick? What's the measure of my second angle? Well, it's given.
3x minus 20.
Yeah, 3x minus 20. Okay, so we know this is our first angle on the left. We have our second angle on the right. And we know that the measurements of the two angles are equal. So we've got to find a number for x that when we plug it in on the left, and then we plug it in on the right, we get the exact same answer. Okay, so let's find x. Okay, what's my first step, Selena, to get x by itself? Subtract what? Sure, we could subtract 40 from both sides. Okay, so that cancels out, and we get x equals 3x, negative 20 minus 40. Luke? Negative 60. Okay, since we decided to put all our numbers without x's on the right, now we have to put all the numbers with x's on the left. Okay. That's the choice that we made in this problem. Okay, so Rose, how would I get 3x on the left?
You subtract 3x.
Yep. So by doing it the way we did it, we ended up with negatives, okay, on both sides, which is fine. It's going to cancel out. Okay, so we have x minus 3x, that's negative 2x, equals negative 60. And how about Denver? What would be my last step to get x alone? Perfect. Okay, divide by negative 2. Divide by negative 2. Okay, so in this case, Eric, x comes out to 30. Yeah. And we'll put our degree symbol. So x is 30. Is that the measure of angle 1? Well, Brian? Is 30 degrees the measure of angle, say the angle on the left? No, 30 degrees is just what?
X.
That's just x. Okay? So if all I want in this problem is x, we're done. But how would I get the measure of the angle on the left? What would I do with x?
You would add it to 40.
I'd add it to 40. Okay, so if I wanted it, I'd plug it in, and I'd get 30 plus 40, or get 70. So if the angle on the left is 70, how about Dakota? What does that mean about the angle on the right? Okay, we could plug it in and do the arithmetic out, but what do we know about these two angles already?
They're equal.
Well, their measures are equal, right, but the angles are congruent. So if the one on the left is 70, then the one on the right is 70. Okay, we could check it, and that would be a great way to make sure we did it right. 3 times 30 is 90, minus 20, 70. Okay, so by checking it, we know we're right. Okay, any questions on those steps? All right, so eventually, maybe not tomorrow, but within the next week or so, we're going to start looking at what's called a proof in geometry. And we have to make sure we know our steps, okay, when we do a proof. So that's why I'm showing you everything step by step. All right, so for tonight, okay, I don't think you're going to need a compass or a straight edge in the homework. Tried to pick problems where you wouldn't. Well, straight edge you might need, but you won't need a compass. Okay, so I want you to do all 2 through 12 even, 22 to 28 even, 32, 38, 44 to 46, that's all. That's the only odd problem you have to do, 45. And then 54.